Hello, I welcome you all to your own channel MSK Learnium. Now in this video we are going to learn about the stability of a four-wheel drive moving in a curved path, right? So in previous classes we already discussed about the precisional motion and the gyroscopic couple, right? So now in this video we will see that how the four-wheel can be stable when it is traveling on a curved path, right? So for that we have to consider one four-wheel is there of ABCD, right? That wheel of the four wheel is a ABCD and it is taking a turn. Either it can take a left turn or right turn on a curved path, right? Then we have to see what are the reaction can act on the wheel. So if you see, the three types of reaction will act basically. That one reaction because of the weight of the vehicles, and the second is due to the gyroscopic couple. Gyroscopic couple in the sense that because of the wheel rotation and because of the engine movement. Third type of reaction will act, which is because of the centrifugal force. Why? Because the vehicle is taking a turn on a curved path. So because of this curvilinear motion, there is a centrifugal force will act. Due to that centrifugal force, the couple will generate, and then because of that couple, the reaction will produce. So one by one we will see. So let's first of all, you have to draw a four-wheeler, which means on which we have to consider the four wheels, that A, B, C, D. So let's start that. Now we are going to draw a four-wheeler, the schematic layout of a four-wheeler like this. So in a simple way you can draw this on your paper, right? So this is how it looked like. So this is one wheel. This is the another wheel of the four wheel. This is another wheel, and this is the another wheel, right? So these are the four wheel you have. Let's say this is the A, and this is your B, this will be the C, and this is the D, right? So first of all we have to consider the center of gravity of this four-wheeler is lying at the intersection point, right? So the center of gravity, you can say, let's say this is like this, this is like this, this is like this, so this is like this, right? So the center of gravity first you have to locate. So this is one line, one diagonal you can say, and this is the another. Okay, so this is the point where the whole mass or whole weight of the body can act, right? Whole weight of the vehicle can act, and this center of gravity is lying vertically upward, right? So let's say the center of gravity will be like this, that we can say CG. Is it or not? Now, so we can imagine that the vehicle, the four-wheeler, is running on a curved path, right? So either it can take left or right turn. So let's say that in this case we are considering that vehicle is taking a left turn, right? So when it is taking left turn, so like let's say this is like this, that is it is going towards left, right? So the vehicle takes left turn. So now when the vehicle takes left turn, it means that the wheel A and C will be the inner wheel and B and D will be the outer wheel, right? So for that we have to consider some nomenclature, that mass of the vehicle's weight and moment of inertia, radius, and all those things. So it is on the screen, we have already written, right? So let us see here, just write down that let M is the mass of the vehicle in kilogram, W is the weight of the vehicle in newtons, that will be equal to mass into gravity. RW is the radius of the wheel, capital R is the radius of curvature with which the vehicle is taking turn, right? H is the distance of center of gravity vertically above the road surface. X is your width of track. IW is the mass moment of inertia of one of the wheel. Omega W is the angular velocities of the wheel or velocity of a spin in radian per second. A spin is nothing but on which the speed at which the velocity is vehicle is running, right? Or the wheel is rotating. IE is the mass moment of inertia of the rotating part of the engine. That means maybe the camshaft, gear, and all those things. Omega is the angular velocities of the rotating part of the engine in radian per second. G is the gear ratio. You can say that the gear ratio is nothing but angular velocities of engine by angular velocities of wheel, or you, in another way you can say that gear ratio is the ratio of angular velocities of rotating part to the angular velocities of the wheel. Now V is what? Linear velocity of the vehicle. That V is equal to omega W into RW, means angular velocities of the wheel into radius of the wheel. Right. So these are the nomenclature. You do one thing, you pause the video and write down this. Okay. So now first of all, as I told you, that vehicle is running on a path, means on a curved path. So because of this because of the curvilinear motion, the reaction will act. Right. So three reaction we have to take in, we will take into the consideration. That first of all, you know that let's say the weight of the vehicle is W, right? So that weight will act downward, is it or not? So, and these weight will be equally distributed on all four wheels, right? So the weight on all four wheels is what? W by 4, W by 4, W by 4 and W by 4. It means that each wheel will apply the force on the road with an amount of W by 4, W by 4, W by 4, W by 4. At the same time, when the load is applied by the wheel on the road, then the road will also apply the reaction force on the wheel. So that reaction force will be vertically upward with same magnitude with which the wheel is applying the force on the road. So the wheel is applying the force on the road is W by 4. So the reaction by the road on the wheel is W by 4, but it is in the upward direction. So first reaction you can say, I'll show you here. We will show here the reaction. So first reaction is on each four wheel by the road is W by 4, and this is the upward. Right. So this is W by 4. Here also you have a W by 4, and here also you have a W by 4. You understood? Right. So if you want, you can write down this statement that why we have taken into the consideration that W by 4. So you can make a point that road reaction over each wheel is equal to what? Is equal to W by 4. That is, W is nothing but the mass into gravity by 4. Right. So now we found out the, because of the weight of the vehicles, the reaction on each wheel by the road is W by 4, W by 4, W by 4 in upward direction. Now the wheel is rotating and the engine part is also rotating. So because of the wheel rotation and due to the engine rotation, there is a couple will produce, right? That couple we call it as a gyroscopic couple. So now we are going to consider the effect of the gyroscopic couple, and because of this gyroscopic couple, the reaction will be developed. That reaction we will see, right? So first of all, you can write that the effect of gyroscopic couple. So here you can make a point, that is effect of gyroscopic couple, right? So effect of gyroscopic couple. So now we see the vehicle takes a turn towards left due to the precision, and the other rotating part, gyroscopic couple will act. So as the vehicle is not running on the straight path, right? If they will run on the straight path, there is no precisional motion. But the vehicle is start running on the curved path. So because of that, the precision motion will takes place, right? And then the gyroscopic couple will act. So that gyroscopic couple we are going to find. So gyroscopic couple we will find due to the wheel rotation and due to the engine rotation. So first we will find the gyroscopic couple due to four wheel, right? So you can write that gyroscopic couple due to four wheel, right? You have a four wheel is there, so that's why you can write four wheel, right? And that gyroscopic couple values is what? IW omega P. right? That is I omega omega p. So gyroscopic couple due to 4 wheel. So we can say CW means couple is the C and the suffix W is for the wheel. So it is the 4 IW into omega W into omega p, right? Where IW is what? Mass moment of inertia of the wheel, omega W is the angular velocities of the wheel, and omega p is the angular velocities of precision. So now we come to know the gyroscopic couple due to the 4 wheel. This is the magnitude. Here you can write omega p is the angular velocities of precision, right? Angular velocity of what? Precision, right? Precision, you know that whenever the body changes its axis, means axis of rotation will change, precisional motion will come into play, right? So this angular velocities of precision magnitude is what? That you can write here itself, omega p is equal to V by R. V is nothing but the velocity with which your vehicle, your four-wheeler is running on the road, okay? And R is what? Radius of curvature, on which radius the vehicle is taking a path, a curved path, right? Or radius of the curved path, right? So now we can say the gyroscopic couple due to the engine movement. So you can write next gyroscopic couple due to what? Due to engine or rotating part, anything you can write due to engine, or it's better rotating part. So rotating part means, when I say rotating part, it means sometimes they will say due to the gear rotation, camshaft, right? Crank, these all are the rotation means give you the rotational motion due to rotating part, right? So there is a one rotation only, means one part only we have. CE is equal to, C is the couple and E is the engine, that suffix E is for the engine. So you have a mass moment of inertia of engine, angular velocities of engine, and angular velocities of precision, right? So this is the gyroscopic couple due to the engine or due to rotating part. Now we need to find out the total gyroscopic couple or net gyroscopic couple. So net gyroscopic couple is what? It's simply the summation of gyroscopic couple due to the four wheel plus gyroscopic couple due to the rotating part. All right. Now, so you can write here that, yes, just hold on. Then you can say next that net gyroscopic couple, net gyroscopic couple, right? Net gyroscopic couple. So net gyroscopic couple, let's say C is equal to, I will write CW plus minus CE. This is the net gyroscopic couple you got. Means whatever the CW you find and whatever the CE you find, just simply you can put this into this equation, you will get. But here the confusion you will arise, that plus and sign minus. So when we will use the positive sign and when we will use the negative sign to get the net gyroscopic couple. So listen very carefully. When the wheel and engine both are rotating in the same sense, right, then we will use the positive sign, and when the wheel and engine are rotating in the opposite sense, we will use the minus sign. Means what? That suppose the wheel is rotating in clockwise direction, engine is rotating anti-clockwise, or the wheel is rotating anti-clockwise and engine is rotating clockwise, means they are opposite in direction. So in that case you have to take minus. If the wheel is rotating in clockwise and engine is also rotating in clockwise, or wheel is rotating anti-clockwise or engine is also rotating in anti-clockwise, that means it is in same sense. So positive sign we can write, but it's better that we can write this. So you can say in short, positive sign will take when wheel and engine both rotates in same sense, right? Both rotates in same sense. I already explained you, right? That is what is same sense and what is opposite sense. And negative sign will take when both means wheel and engine, right? Both are rotating in opposite sense, right? Opposite sense means what? One is clockwise, another is anti-clockwise, one is anti-clockwise, another is clockwise, and vice versa, opposite sense, right? Sense. Okay, so please make this note. Now whatever the gyroscopic couple we got, that is net gyroscopic couple I am talking, so that due to the wheel rotation and due to the engine rotation, because of this gyroscopic couple, there is a reaction will act on the wheel, right? And that reaction will be the upward in on outer wheel and inward means downward on the inner wheel, right? And that reaction we can denote by P. So now you can see that here you'll go make a point due to net gyroscopic couple, that means the above gyroscopic which we have discussed just now, net gyroscopic couple, right? The vertical reaction on the road surface will produce, on the road surface will, sorry it's not working, on the road surface will produce, right? Will produce, and that magnitude you can say the P by 2, and this you can make a point here only, that and this reaction, this Rxn is the reaction, this is the reaction, right? And this reaction will be vertically upward on outer wheel, right? On outer wheel, this is the key point, right? Outer wheel, and downward, that is vertical downward on inner wheel. That is very, very important point you can say. So you have to remember, right, while you getting the reaction on the four-wheeler, right? So now magnitude, what is the magnitude of that such reaction? So we can say the magnitude of that reaction is P. So you can consider, let the magnitude of this reaction is P, right? So actually this P is distributed on outer on inner wheel, so we can find the reaction on outer and inner is the P by 2. So first of all we can say P is equal to P into X, that is P is the reaction, is nothing but the force, and force into distance, X is what? Width track. That will give you the gyroscopic couple, net gyroscopic couple due to the wheel and engine rotation. So if I want to know the P magnitude, so P is equal to what you can say? So P is equal to C by X, very good, right? So this is the P on one wheel actually, so but we are considering outer and inner, right? So you can say therefore the vertical reaction at each of the outer and inner wheel, okay, outer and inner wheel is equal to what? That is equal to, you can say P by 2 is equal to C by 2x. Why? Because in outer you have a 2 wheel and inner you have a 2 wheel. So now we can show the magnitude, whatever the figure we have drawn, that schematic layout of your four-wheeler, right? So this reaction, whatever the reaction you got, that is P by 2 due to the net gyroscopic couple, is acting downward on the inner wheel and upward on the outer wheel. So you can see when the way your vehicle is taking left turn, so this A and C, the wheel A and C is the inner and the B and D is the outer. Don't be confused. If it is taking right turn, so these two B and D will be the inner and A and C is the outer, right? So now you can say inner means this is, and the reaction we got which is P by 2. So here also we have a downward, that is P by 2, but on outer wheel this reaction P by 2 due to the net gyroscopic couple you got the upward, right? So this is very important, you have to shown, right?